How's it going, everybody? My name is William Lynch, and we're going to be going over the garbage management plan for the new ship. So, uh, we're going to be talking a little bit about the MARPOL 73-78 Annex, which prevents marine pollution from ship generated garbage. It also requires a garbage management plan, outlines procedures for handling and storage and disposal of garbage, and then it's going to designate responsible duties for shipboard personnel, and then also going to specify discharge areas while we're underway. So some of the processing equipment includes uh, the compactor made by Compactor Inc. The capacity is 8 cubic feet per hour with a 13,500 pound force. Then we have a plastic waste melter for all the plastic garbage, which has a capacity of 220 pounds per hour. And then lastly, the incinerator, which is an Atlas 1500, and that's going to have a solid capacity of 920 kilograms per hour, and then sludge capacity of 258 kilograms per hour. And so this is the garbage management plan. Uh, so basically, it's going to go to sorting, and it's either going to go to dischargeable garbage or non-dischargeable garbage. And so the dischargeable garbage can either go to not be processed or to the compactor, incinerator, or grinder, and this just depends on what kind of food that you're processing or what garbage you're processing. So, and then after that, it can go to discharge area and either be put overboard or sent off to storage for port disposal. And then the non-dischargeable um, garbage can either go to no processing, um, the incinerator, or a grinder. And then after that, the incinerator ashes can either be dumped overboard or brought to storage for port disposal. So some of the shipboard responsibilities. There has to be a garbage management plan posted in all handling areas. This explains restrictions and penalties for unlawful discharge of garbage. Um, the crew must also properly segregate all garbage, and then there will be assigned personnel to collect and transport waste, and then plastics must be retained on board for port disposal. So this is the incinerator control. It's kind of just an overview of the parameters of the incinerator. So you need to preheat the chambers before adding any waste. Don't overload it. So the max chamber volume is 20% that you can add at a time. Do not burn explosives or steel containers. Must maintain required combustion temperatures so that all waste is burned. And then need to follow all shutdown procedures for the incinerator. So some penalties for non-compliance, there are heavy fines and legal penalties, such as vessel detention by port state control, criminal liability, and damage to your company's reputation. So the garbage record book requirements, all discharges at sea must be recorded. So this includes the incinerator operations, uh, deliveries to port, entries have to be signed by a responsible officer, and volumes must be recorded in cubic meters. So lastly, receipts into tracking, which is done by the master captain. This confirms the type and quantity of garbage landed, tracks volumes before and after processing, and this shows MARPOL that there's an accurate documentation of garbage.
It is a requirement under MARPOL 7378 Annex 5 to have a garbage management plan on board the vessel. It is crucial that all crew on board follow this plan. The plan will outline procedures for handling, segregation, storage, and subsequent disposal of ship's garbage, as well as a plan being placed in all locations of major garbage handling. The plan will also name the person on board responsible for the management of the plan. Use of a garbage management plan facilitates subsequent shipboard processing and minimizes the amount of garbage which must be stored on board a ship for return to port. The ship's plan requires garbage to be collected and separated into different categories. The plan also instructs the crew on how collecting and emptying of receptacles will be done, as well as the transport to storage or processing areas. The image on the right is an example of a ship's garbage management plan under MARPOL. The main garbage categories include, but are not limited to, plastics, food waste, oily and contaminated rags, and other garbage such as paper, glass, metal, dunnage, and incinerator ash. Each of these categories have different disposal requirements. Storage and disposal rules. Plastic garbage must be retained aboard the ship for discharge at port reception facilities. If incinerated, then the residue, ash, and plastic clinkers from plastic incinerated solid waste should be retained on board until a suitable shoreside facility is available. When plastic garbage is not separated from other garbage, the mixture must be treated as if it were all plastic. Food will be disposed of overboard. Precautions must be taken to ensure plastics contaminated by food wastes, like plastic food wrappers, are not discharged at sea with other food wastes. Oily and contaminated rags or cotton waste must be kept on board and discharged to a port reception facility or incinerated. If stored on board, such materials should be kept in a steel container fitted with a secure airtight lid and stowed away from any hazardous areas. Disposal of some other garbage not listed will be done at port reception facilities. It is also a requirement to maintain a record of each garbage discharge operation. This includes all discharges to sea, to reception facilities, in port, or to other vessels. All operations are to be recorded in the garbage record book.
I'm Dylan Farmer. Next, we're going to be talking about the garbage compactor, the plastic waste melter, and the benefits of using the equipment and the procedures. The model of the garbage compactor used on board the T-Summit is a TA4500SS. Processes about 8 cubic feet of garbage per hour and produces about 13,500 pounds of compacted force. The motor is a 120 volts. The machine works by using a hydraulic ram to compress the waste, turning it into a dense block. By compacting the garbage, we're able to save a significant amount of space on board the vessel. It also makes the waste much easier to manage and organize. In addition, it helps keep the garbage areas cleaner and more controlled. Since you'll not have hundreds of loose garbage bags to deal with when entering port, it'll be a lot easier. It's important to note that all oil rags, contaminated rags, must never be put in the garbage compactor. They must be put in a unique, separate handling or area. Next is the plastic waste melter used on board. It's a GreenMax M-C100, which has a processing capacity of 220 pounds of material per hour. Also, the motor runs at 120 volts and at 22.9 kilowatts. It works by feeding plastic into the machine, where the plastic is then heated and melted. After melting, the plastic is compressed and formed into a tightly packed block. similar to how the garbage is compacted in the trash compactor. The purpose of the system is to reduce the volume of plastic waste, making it easier to store on board and dispose of when the ship reaches port. It is also important to note that oil rags, contaminated rags, cannot be placed in the plastic melter or trash compactor. They still must be in their own safety containers. In addition, plastic and non-plastic waste must be separated processing. If the waste is not properly separated, the entire load trash must be treated as plastic waste, which will increase the amount of material that must be processed by the melter. And then we have processing benefits. One of the biggest advantages to using waste processing equipment like the garbage compactor and plastic waste melter is the reduction in storage space needed on board. Ships produce a lot of waste every day and space is very limited, so reducing the size of the waste is extremely important. By compacting garbage and melting plastic into dense blocks, the ship can store much more waste in a smaller area until it reaches port for disposal. These systems also improve safety and cleanliness on board. Loose trash can create sanitation issues, unpleasant odors, and even safety hazards in the work areas. Processing the waste keeps garbage organized and contained. And finally, these systems help ships comply with international environment regulations like MARPOL, which are designed to prevent pollution and protect the ocean.
Hello, my name is Connor Phelan, and I will be focusing on the incinerator system design and components. On the training ship State of Maine, we will utilize the Atlas Model 1500 SLBWSP. This is a robust unit that is designed to handle both solid combustible materials and waste oil or sludge. This system is a powerhouse with calorie capacity of 1,290,000 kilocalories per hour, which is roughly 1,500 kilowatts. To give you an idea of its processing power, it can handle up to 920 kilograms per hour of solid waste and up to 258 kilograms per hour of liquid waste. It operates primarily on marine gas oil, which is a minimum viscosity of 2 CST at 40 degrees Celsius, and is supplied from either the number 2 or the number 3 MGO service tanks through the incinerator fuel oil pumps. Moving on to the heart of the system, the combustion design, the Atlas incinerator uses a dual chamber approach that ensures complete thermal destruction and environmental compliance. The primary combustion chamber is where the solid waste is loaded and the sludge is initially burned. Safety is paramount here, and the chamber is equipped with an ash door switch and a sluice switch to ensure that the unit cannot be opened or operated unsafely during the burn. The secondary afterburner chamber is where the flue gas from the primary chamber passes into the secondary zone. Here they undergo further combustion to eliminate unburned particles and minimize emissions before exiting through the flue gas outlet and funnel. The burner configuration: the system features 2 high-pressure MGO burners. The primary burner has a capacity of 30.3 liters per hour, while the secondary burner handles 22.8 liters per hour. Each is monitored by its own flame detector and thermocouple to ensure stable combustion. Several critical components that work together to keep the system running efficiently is the sludge dosing pump, the primary blower, the circulating and mill pumps, and the sludge tank heaters. So the sludging dosing pump is a progressive cavity pump which is equipped with a VFD, and it precisely regulates the sludge flow to the primary burner, and it ranges from 45 to 210 liters per hour. The primary blower is a high-pressure centrifugal fan which provides massive amounts of air required for combustion and delivers 14,800 cubic meters per hour. The circulating and mill pumps within the sludge oil mixing tank. The mill pump grinds the homogeneous and waste to prevent burner clogs, while the circulation pump keeps the fluid moving to maintain a consistent temperature. The sludge tank heaters is used in the mixing tank and is electrically heated and controlled by a regulating thermostat. It includes multiple safety levels, including the high, the low, and even extra high and low switches to prevent overflow or pump dry running. Finally, let's look at how this is all managed. The entire operation is governed by a PLC-based control system. The PLC automates the complex startup sequence and monitors all vital signs. This includes constant tracking of temperature and pressure via thermocouples and pressure switches, such as the primary air blower pressure switch. If parameters fall outside of safe limits, for instance, if a low level is detected in the buffer tank or a flame failure occurs, the system triggers immediate alarms. The incinerator's control panel consists of a main start-stop switch, an abnormal alarm indication, and a touchscreen. The operator interacts with the system through a touchscreen display, which provides a real-time mimic of visual overview of the system status, active pumps, and current temperatures in both combustion chambers. This ensures that we can manage the ship's waste safely and efficiently at both touch of a button.
So the first mode we'll be talking about is the solid waste mode. Prior to starting, before operating the incinerator in solid waste mode, it is important to understand that you should never put solid waste with too high of heating value into the combustion chamber before the primary burner is operating and a flame is visible through the sight glass. You should also never put more solid waste than the recommended amount for the specific incinerator size. You also must select solid mode on the control panel display. So after doing what you need to do before you start it up, you can now start up the incinerator. To start it up, you must turn the start-stop switch to the start position, which then activates the primary blower, which will run until the switch is turned to the stop position. At the same time, the impeller for the primary and secondary both start, and the MGO circulation commences circulating through the burners and back to the MGO tank. A 30-second purge cycle begins for the primary and secondary burners. An hour counter then begins to track how long the machine has been running. So now for the preheating. When the 30-second purge is finished, the secondary burner lights, first burning the MGO and heating all the combustion chambers to the proper operating limit, acting as a preheater for the incinerator. So now we get to the start of the combustion. When the secondary burner reaches 100 degrees Celsius, the primary burner then ignites, also burning MGO. The secondary burner will continue to burn, and then when the temperature reaches 650 degrees Celsius, solid waste bags will be fed into the secondary chamber at this temperature, waste can burn effectively, cleanly, in a controlled manner. When the incinerator is running, there is automatic burner controls for both burners. These automatic controls can start and stop the burner based on the current temperature in the combustion chamber. If there is a temperature drop, the burner ignites, and if the temperature gets too high, the burner stops until the temperature is regulated. For every restart of the burner, there's also a 30-second delay for the purging of the burner. The incinerator uses flame detectors to monitor the flame and sends signals to the flame control circuit. If the flame stops for any reason after 1 second, an alarm will activate and all the oil valves will close except for the quick closing valve, which will stop the fuel supply to the incinerator to prevent flooding of the furnace. So for the operation of the secondary burner, when the secondary chamber reaches 930 degrees Celsius, the secondary burner shuts down and the solenoid valve and the fuel line closes, cutting the fuel, and this is done to prevent overheating of the combustion chamber. When the temperature drops to 870 degrees Celsius in the combustion chamber, the system restarts and the solenoid valve opens back up, and then after the 30-second purge delay, the burner will ignite again. To stop combustion, you must turn the stop-start switch to stop position, which will then activate the incinerator cooling shutdown process, and the solenoid valves will close. When the temperature drops to 100 degrees Celsius in the primary combustion chamber, the cooling shutdown process stops, but it may be repeated a few more times if need be. At this time, the primary blower and burner air impellers stop as well. So the next mode we'll be talking about is the sludge waste mode. Prior to starting, you must select solid and oil mode on the control panel display. The starting and preheating process are the exact same whether you are burning sludge waste or solid waste. At 650 degrees Celsius, the primary chamber sludge oil dosing pump will start and the sludge will begin to burn. And at 652 degrees Celsius, the air dampener in the sludge oil burner will open, providing more efficient air for combustion. Or more air for efficient combustion, sorry. At 840 degrees Celsius, the primary chamber the burner will shut down and the solenoid valve in the fuel line will close. The operation of the secondary burner as well as the incinerator shutdown for sludge waste and solid waste are the exact same. So the next one we'll be talking about is the simultaneous burning of solid and sludge. The combustion temperature must be set to 850 degrees Celsius on the control panel display and also must be set to solid and sludge mode. To have low emissions when simultaneously burning sludge and solids, you must first start by burning only sludge for 1 hour to preheat the combustion chamber. Following this hour, the control panel should be then set to solid and then the solids should be burned alone for 1 hour. After 2 hours of doing this, you can switch the control panel back to solid and sludge mode, and the solid and sludge waste can be mixed together simultaneously to burn.